Okay, welcome to this next in our series on 5 random GCSE questions. And these are calculator questions from papers 2 or 3. First question is about transformations. Okay, we've got this triangle P, it's rotated 90 degrees clockwise about the origin. So it would end up here, okay, and if you can't see that, there's two ways that you can achieve this. You could ask for a piece of tracing paper, okay, or you could look at this little example or demonstration here. If I took the center of rotation and put a straight line to that vertex there, okay, this line here to the corresponding vertex is the same length, and it's a right angle here. Okay, so that's showing that a 90-degree rotation has taken place about the origin. You could put a similar yellow line, if you like, to that point and this one, and you'd find that they would also be the same length as each other and at 90 degrees. I then take this shape here, which I've got to now call Q, and I've got to move that according to the translation of -4, 6. So if I move it along 4 to the left and 6 up, it's going to sit here against the previous triangle that we started with. Okay, so it's going to be this position here, okay, and here, and that's going to be R. So I need to draw those on as I go, and then I need to describe the single transformation that maps P onto triangle R. Well, that's also a rotation, okay, and to get from P to R you'd have to rotate clockwise about this point here, okay. It's quite easy to see that, I think. So this is the center of rotation here, but you need to describe it properly, and you must use one of those 4 words: rotation, enlargement, reflection, or translation. I'm going to call it, of course, a rotation. Okay, rotation. You must have that word. You need the angle, so 90 degrees. Okay, and from P to R it's clockwise. And you also need the center of enlargement. Okay, and that's the point about which it rotates, and that is the point with coordinates 1, 5. Okay, so that would get you the marks for that. And under the transformation that maps P onto R, one point is invariant. Write down the coordinates of point A. Well, the point that's invariant is the point that doesn't go anywhere in the rotation, and there's only one of those, and that's the point where the center of rotation is. So it is the point 1, 5. Okay, they give you the space to write that in there. Okay, next question. Okay, this question is about a rocket, and this is a speed time graph. Okay, now the distance covered by the rocket is the area under the graph, and what we're interested in is the distance traveled in the first 45 seconds. Okay, so what we do is we estimate the area under the graph for the first 45 seconds. Well, it's easy to do. We can see that it's going to be a triangle for our estimate, okay, and that's going to be a very good estimate for the actual area, because if you look when I draw the triangle, you'll hardly notice any difference between the triangle and the curve. There's obviously a little bit of curve to the left of the triangle, but it's quite a good estimate of the area underneath. So what's the area of that triangle? Well, it's simply half base times height, so it's half of 45. Okay, so it's a half times 45 times the height, and the height of that is Well, that's exactly halfway between 160 and 200. So that's 180. Okay, and if we put that on the calculator, that comes to exactly 4050 meters. Okay, so that's the first part answered. And quite common in these questions, they then ask you about an overestimate or an underestimate. Okay, and there is also an error in the question here. This should have said 45 seconds here, so I've corrected that. So we can see that our estimate for part A is an underestimate because we haven't included the area between the line and the curve. Okay, and that's basically it. So I've already written that answer out in a way that would get you the mark, and it's there. Okay, an underestimate because it has not included the area between the triangle and the curve. Okay, we now go on to this part of the question. Jolene had used this graph to answer this question to work out an estimate of the acceleration of the rocket at time 90 seconds. What she's done is worked out really the average acceleration up to 90 seconds by working out the gradient of the line that forms this triangle here. Okay, so if I were to draw a straight line from 0 up to 90, okay, that has a height of 260, and she's divided it by 90 to get the gradient of that red line. Okay, but that isn't the answer to the question because they want the acceleration at 90 seconds. So that means the steepness or gradient of the line at 90 seconds. Well, I'll do that in a different color. I'll do that in blue. It's roughly this line here. Okay, so if I take a point, say about here, okay, that is an estimate of the gradient of the curve at 90 seconds, you see, because it's a tangent that's just touching the curve there. Okay, so I'm just going to call that L. Now we don't actually need to write out or work out what that gradient is. We could do by just constructing a triangle around it. But all I need to do is explain why Jolene's method is wrong. So what I'm going to say is this. Okay, I'm saying what she has done. Okay, Jolene has found the gradient of the triangle. She should have found the gradient of the tangent, which I've called L. Okay, and that would get me the mark for that question. Okay, next. Okay, this is about two investments. They both invested X pounds, and this one was done for 3 years at 3.5% interest. And we know at the end of that period that Lola had this much money. So we can work that backwards to find out what the investment X was when she started. So we know that if we took X, okay, whatever it is, and we multiplied it by 1.035 cubed, that's how you do a 3.5% interest increase 3 years in a row. Okay, we would get this 310441. So by rearranging that, we can say that X must be equal to 310441, okay, divided by this thing here. Okay, and if you put that on the calculator, that will give you, in fact, very close to 280,000. In fact, it goes 279,999.99. Okay, so to the nearest pound, it's certainly 280,000. So if we go over to this side, then what we're interested in is the amount of money at the end of 4 years for Sua's investment. So that's done like this, 280,000, okay, which is the same amount that Lola invested, but in this case we increase it by 2.5% to the power of 2 because we're doing it for 2 years, and then we times it by 1.03 for another 2 years, and that will give us the amount of that investment, and it comes out to be 312,090. Okay, and that's the answer to the question. Okay, the next question. And here we have some trigonometric graphs. Okay, so I'm just going to label this one part A because that seems to be missing from the copy here. So that's question A. All right, and it says using this graph find estimates for all 4 solutions to this equation for x between 0 and 540. Well, the graph only goes up to 360, but that's not a problem because this is what we do. Sine of x is 0.4. 0.4 is there, okay? And so we just draw a straight line. Now, we don't have to go any further than that. We can imagine what would happen beyond 360, or we can see what would happen. But let's first of all work out these 2 values that we can see. So we know that this one here we can work out pretty accurately from the graph. A good estimate would be, well, each of these little tiny squares is going to be worth 6 because that's 30 degrees there at 60. So each little one's worth 6. So that's 24, okay? 24. And that we couldn't get it any more accurate than that from this graph, okay? And this one here would be, well, we can easily see what it is. It's 24 less than 180, okay, which is 156, okay? So those are both to the nearest degree from our graph. So they're 2 of the solutions, okay, but it's wanting 4 of them. So let's just write those down first. So x would be equal to 24 degrees and 156 degrees. And what then happens to the sine graph after 360? It just repeats itself. Okay, so the next solution would be 360 plus 24, which is 384. And the final solution in the range given would be, well, it'd be 360 plus 156, which is 516. Okay, and then after that there wouldn't be any for quite a few hundred. That would take us past the 540. In any case, we can see that we've now got the 4 solutions that it asked for. Okay, so in this part B, they're simply asking us to take the graph of y equals cos x, which they haven't drawn, but they want us to reflect it in the x-axis. Well, all you need to know is that the graph that you get would be minus cos of x, okay? Because when you reflect something in the x-axis, all of the positive y coordinates become negative ones and vice versa, okay, and all the x coordinates stay the same. So it basically reflects it in the x-axis. So that's all you need to do, and that's the answer. Now in part C we have a graph translation, okay, because when you add or subtract something you translate the graph. Now, when you add something to the x term in the function, you move it to the left that number of places. So basically this graph moves 3 places to the left. So instead of being starting at -4 up here, it's starting at -7. Okay, and it's going down to there. It's going across by the same amount, which is just 1 unit across. Just get the gradient right. It's going along 3 and up 2. So let's make sure we get that right. So it's starting here and it's going along 1, 2, 3 and up 2 to there. Okay, so that's the required answer. Okay, and that's the end of that question. This is a question about bounds and calculations using bounds. Okay, so this is a classic question because it has a division, and I'll show you why that's significant in a moment. So you need to get some marks early on, and it's very easy because you've got to get the upper and lower bounds of these two numbers first. So we normally do a little table. This is what I would encourage you to do. So we just set up a little table. So we've got L for length, L and G for that's the acceleration due to gravity, and then we've got the lower bound and the upper bound of each. Okay, so that's our little table. Just put in a few lines there. Okay, like that, and then we have a couple of verticals in there as well. Okay, so there's our little table to work with. And what we've got to do is just put the lower bound of L in first of all. Well, if that's given to 3 significant figures, it could have been as low as 42.45, or it could have been as high as 42.55. Well, up to, but not including 42.55, but we define the upper bound as the actual switchover point. All right, so the upper bound is defined as 42.55, and similarly for G, the lower bound could have been 9.805. That's the smallest number it could have been, so that is the lower bound, and the upper bound is 9.815. Okay, the point at which it would switch to 9.82, you see. Okay, so now we've got those 4 bits of information. There's always marks for that part of it. We now need to deploy it in this calculation for t. So what we're going to do is find the lower bound of t first of all. Okay, lower bound of t. Okay, and that equals, now they're telling us to use this value for pi, so we don't argue with them. If that's what they tell us to use, that's what we use. Well, 2 times pi is 2 times that, which is 6.284. Quite easy to see that, so I'm going to write that down. 6.284. Okay, and then we need to multiply it by, now to get the lowest possible value of t, we need to minimize the numerator and maximize the denominator. So what we're going to use is the lower bound of L, which is 42.45. Okay, and we're going to divide by the upper bound of the value of G, which is 9.815. Okay, and then we're going to put the square root sign and the fraction sign in there. Okay, so that's what we need to work out. Now we can put that on the calculator, of course, because it's a calculator paper, and that comes to Well, it's 13.0686, 13.0686, and it goes on after that. All right, now we do the upper bound of t, and that's going to be also 6.284, because that's what it's telling us to use. And the square root thing, well, if I take a copy of that for the moment, save a bit of time. So if I take a copy of that, put it down there, but what I've got to do, of course, is edit the numbers in there. So the number at the top would now become 42.55. So I'm now using the upper bound, and this would be 0 here. Okay, so that's now the upper bound of L and the lower bound of G, and that result comes out to be 13.09, okay, which is obviously bigger, as you would expect. So that's 13.09, 06, etc. Okay, now it doesn't say in the question how many significant figures to give your answer to. What they often do in these questions is ask you to state a single answer for the value of t that you can reliably give. In this case, it would be 13.1, because they both agree to three significant figures to be 13.1. Okay, but it hasn't actually asked us that. It's just asked us to work out the upper and lower bounds, and the marks will come from seeing that working there. Okay, so you've got to show your working, and any calculation that used the lower bound of both of them in the same division, in the same part. So if I use the lower bound of that and the lower bound of that, would get no marks, because it means a misunderstanding of the question. You'd get marks for this bit here. Okay, so just be careful. A lot of work to do on these questions, and a lot of accuracy is needed. Okay, and that's it.